All right, students, so we are getting really close to actually graphing these functions. We've talked about all the asymptotes and the holes in the graph. Now I want to talk about some other parts of the graph really quickly. In this video, part 2 of 4C.2, we're going to talk about the x-intercepts of rational functions. In order to find the x-intercepts, basically, factor it. You've already done that because you looked for the vertical asymptotes. Reduce. You've already done that because you have looked for the holes. So you've done this kind of legwork already at this point. You just let the numerator that is left over after you factor and reduce be equal to 0 and solve. Very simple, very easy to do. I'll show you real quick. In our first example, we actually didn't cancel anything out or factor. We just had 3x minus 4 over x minus 2. So we're back to those guided notes that we had before. So all we do is we take that numerator, that 3x minus 4, and we set it equal to 0. Add 4. Divide by 3. Now 4/3 is the same thing as 1 and 1/3. So on the graph, this function is going to cross the x-axis at 1 1/3, about right here. Since we know the graph is going to cross here at 1 1/3, we'll go ahead and put it over here as 1 1/3, comma 0 as the x-intercept. That's the point where it's going to cross the x-axis. In example 2, we don't have an x in the numerator, so we're going to have a little bit of a problem here. We really can't set it equal to 0. That doesn't make sense. There's no variable there. So why is there no x-intercept? Look at the graph. Look at what we've already decided here. There is a horizontal asymptote at y equals 0. So this function is probably, well, in this case, it's not going to cross the x-axis because of that asymptote. So there is not going to be an x-intercept because it doesn't cross the axis. That happens sometimes. In this case, we are good. There is no x-intercept. Example 3 from our guided notes. If we set x plus 5 equal to 0, we get negative 5. And if we set x minus 3 equal to 0, or we're just looking at the numerator, we get x equals 3. So we should have an x-intercept at negative 5, and we can put that on the graph. And at positive 3, and we could put that on the graph. Those are going to be the two x-intercepts in this graph. We've got negative 5 comma 0 and 3 comma 0. In example 4, the 5 doesn't have a variable, so there's nothing that we can do with that. We just set the x minus 1 equal to 0. We get positive 1, so that's the point 1 comma 0. It's going to cross the x-axis at 1. So you can see how once you've done the other legwork, once you found the asymptotes, this part is really fast to do. You're just looking at that factored form of the numerator if it has a variable and setting it equal to 0. This one has an asymptote on the x-axis. There's no variable in the numerator, so there's not going to be an x-intercept. And finally, in example 6 on our guided notes, again, asymptote on the x-axis, no x-intercept, not possible. There's no variable in the numerator for us to work with. Now, I did have some extra examples, so we'll look at those. Remember, this one had a hole at negative 2 because the x plus 2 canceled out, and we had a reduced form. So, if you kind of follow this along, what's left over is f of x equals x plus 1 over x minus 3. Well, for our x-intercept, we're only interested in the numerator. So if we set x plus 1 equal to 0, for that x-intercept, we get negative 1. It's actually going to be negative 1 comma 0 as a point. So negative 1 comma 0 is going to be about right here. And that is the only x-intercept that we have. In our other extra example number 2, again, we had another hole. And what was actually left over from our after factoring everything was just x plus 3. Well, this kind of is our numerator. Yeah. So if I set it equal to 0, I get negative 3. And you can see on the graph that I've already graphed, it crosses at negative 3 comma 0. Now, I kind of want to talk about why this works. Let's maybe go back to example number 4. Why are we only setting the numerator equal to 0? Why not the denominator? Well, if you go back in time and think about in other types of functions how you find x-intercepts. Well, to find an x-intercept, you let y be 0 and you solve. So if I have this function y equals 5x minus 5 over x plus 2. If I let y be 0, how am I going to get rid of the denominator? Well, I'm going to multiply both sides of the equal sign by that denominator. And what's going to happen on the right side is it's going to cancel out. And on the left side, I've got 0 times x plus 2. And what's 0 times anything? Still 0. So the reason you're setting the numerator equal to 0 is because since there is a fraction and we're setting y equal to 0 to find the x-intercept, we would always multiply both sides by that denominator, and that denominator would always disappear. When you multiply anything times 0, you get 0. So we're just focusing on the numerator because that's all we have to do. We don't have to think about this denominator canceling out every time. With this type of function, we can just say, oh, well, it's going to be the top equal to 0. I hope that makes sense, but that's the reason why we're just setting the numerator equal to 0 and not worrying about the denominator. So we've looked at all of our extra examples. We did have this one extra example with the slant asymptote, and I showed you a graph. I just wanted to show you the factored form here was of the numerator was x minus 5 times x plus 1. So we should have an x-intercept at -1 because of the x plus 1, and at positive 5 because of the x minus 5, and we do. So this is a very quick, easy way to find x-intercepts when you have these types of rational functions. I hope that by doing all of these little pieces in isolation, it's not as overwhelming as if I threw it all at you at one time, right? So we're kind of getting to this point where we may start thinking, well, we need to start to graph these functions, and I promise that is coming soon. We've got one more little piece of information to talk about first, and then we'll start bringing it together and graphing the functions and looking at characteristics of the functions before we get to any kind of test or anything. So don't freak out about tests yet. We're going to have lots more practice before we get there. And if you have any questions about this, I will see you in class.